Algebra 2, 3.9b, absolute value functions. And if you haven't seen the previous video, 3.9a, you may get confused, and there's a link in this video's description so you can just click on it, all right? The absolute value is a number's distance from 0 on a number line. The absolute value of 5 is 5 because it's 5 hops away from 0. And the absolute value of a negative 5 is also 5 because it's 5 hops away from 0. Finding the absolute value of a number can also be thought of as a function, the absolute value function. The domain, that's x, of the absolute value function is the set of real numbers, and the range, that's y, is the set of positive real numbers. And the graph is going to have two parts. So remember our terminology here. X can be the domain, the input, the x coordinate. It's also the first set of members in an ordered pair in a relation. And it's also called an abscissa. And the y is the range, the output, the y coordinate. It's also the function of x, and it's the second members in an ordered pair. And it's also called an ordinate. All right? So take a look at this. We've got the function of x is the absolute value of x. Well, all that means is whatever x is, we have the absolute value for the y value, don't we? For the function of x. So if x is a negative 3, the absolute value of negative 3 is a positive 3. See, there's no negatives here because they're all absolute values. The absolute value of a negative 2 is a positive 2. See, the absolute value of 0 is 0. What happens is we get this nice two-part graph that makes a nice V. And look, it meets at the origin 0, 0, doesn't it? See that? Look at this one. Now we're going to take this absolute value of x, I'm going to add 1 to it. And look what the graph did. It went up on the y-axis by 1. Instead of being at 0, 0, it's now at this 0 and positive 1, isn't it? Because we added 1. And what would happen if we added 3? It would be up on the positive 3 on the y-axis, wouldn't it? And if we added 7, it would be up here on the positive 7. See that? And it would still be the same nice V. It just translated up 1 from our original pink one. Remember, translate means to slide like an ice skater. So this whole thing didn't change size or shape. It just translated up 1 because of that positive 1. So if x is a negative 2, then we get the absolute value of negative 2, which is a 2, and we add 1 to it, so we get 3. See that? And if x is a negative 1, the absolute value of negative 1 is a positive 1. We add the 1 to it, and we get 2. We can do that for the whole function table. When we graph it, negative 2 for x and 3 for y is right here. We have this nice point, negative 2, 3. See? We can graph the whole thing that way. Okay? The whole thing just slid up, didn't it, because of that plus 1. Take a look at this. Now we've got the whole thing inside of the absolute value. For this one, the absolute value of x, and then it had the plus 1 on the outside. Now we've got the whole thing inside absolute value bars. So what's going to happen is, if we have a negative 3 for x, we're going to have negative 3 plus 1, which is the absolute value of negative 2, which is a 2. See that? So we get a 2 here. And if x is a negative 2, we do negative 2 plus 1, which is a negative 1, and the absolute value of negative 1 is a positive 1. See that? We can do that for the whole function table. And if you look, this graph translated left 1 from our first pink graph. This one met at 0, 0 at the origin, and now this one is at negative 1 for x and 0 for y. See that? Isn't that cool how that happened? Now take a look at this one. Now we've got a little division with the absolute value. So if the function of x equals x divided by the absolute value of x, it doesn't say x and y, it says x and x, doesn't it? So if x is a negative 3, that means we're going to have a negative 3 numerator and the absolute value of negative 3 denominator. And the absolute value of this denominator, negative 3, is going to be a positive 3, but that numerator is going to stay a negative, isn't it? That's going to give us a negative 1. And it happens for all of these. It's going to end up staying at a negative 1. If we have a negative 1 for x and the absolute value of negative 1, we're going to have a positive 1 down here, but that numerator is going to stay a negative 1. So that means it's going to end up being a negative 1 for our y value. See that? Because these are the same. It doesn't say xz or xy. It says xx. And when the numerator and denominator are the same, it makes a 1, doesn't it? So what happens on our graph is we have all these x values, but all the y values stay at -1. See that? And it makes this ray. And when we come down here to the positive values, if we have a x as a 0.1, well, 0.1 over 0.1, it's the same numerator and denominator, so that's going to be at a positive 1. If x is a 2, then that means we have 2 over the absolute value of 2. Remember? Because they're both the same. So it would be a 2 over the absolute value of 2. Well, that's a 1. And what happens is we get another ray. So we have 2 rays on this one. See how that happened? When you have 3 and the absolute value of 3, whoops, it's just going to be 3 over 3, isn't it? And if that's a -3 and it's over the absolute value of -3, then it's going to end up being a -1, see? Because the numerator keeps its negative. See that? Now there's going to be a link in this video's description to my Grade 8 Math Chapter 9 playlist that talks about transformations and translations. And there's even other videos in the Grade 8 Math playlist that talk about dilations and rotations too. All right? So our next video is 3.9c, and we're going to talk about the composition of functions. And I'm going to add this video to the Algebra 2 playlist so you can use it for studying. And there's also going to be links to the Algebra 1 chapters of graphs and linear equations from Chapter 7 and relations and functions from Chapter 12. Because sometimes going back to Algebra 1 can help you. You'll see more basic tutorials on this, okay? Maybe it's close to the same thing, but I say it in a different way, and you might understand it more, okay? So I hope this was helpful, and we'll talk about composition of functions next. I hope you're going to have a great day. You can do this. Keep trying. I believe in you. You can do this, all right? Bye.